Imagine you're standing in a kitchen, right, holding a knife, and you're staring down at this freshly baked chocolate cake.
Oh, yeah, the classic dilemma.
Exactly. You have two kids staring back at you, waiting for their slices. And, I mean, it sounds simple enough. You just cut it right down the middle, 50-50.
Right, equal pieces.
Yeah, but then one kid speaks up and says, wait, I should get a bigger piece because I totally skipped lunch today.
Mhm.
And, before you can even process that, the other two chimes in, no way, it's my birthday. I deserve the bigger piece.
Right, so now the math is out the window.
Totally out the window.
Yeah.
Suddenly, that perfectly mathematical 50-50 split, it doesn't seem to actually solve the problem. How do you define what's actually fair in that moment?
Well, it really becomes a question of what we're prioritizing. Like, are we prioritizing need because one kid is hungrier? Are we prioritizing status because it's a birthday? Or are we just strictly enforcing equality of outcome, regardless of the context?
Right. And welcome to today's deep dive.
Right.
Because we are taking that exact cake-cutting dilemma and applying it to something that silently governs, like, almost every aspect of your life today.
Yeah, the algorithms.
Exactly. The algorithm's deciding whether you get approved for a mortgage or, what job ads pop up on your social media feed, and even how secure the facial recognition is on your smartphone.
It's a topic that, honestly, it feels highly technical and abstract, but at its core, it's profoundly human. I mean, we are essentially teaching machines how to make moral judgments.
Yeah. And today, we're drawing from this incredibly comprehensive entry in the Stanford Encyclopedia of Philosophy. It was written by Deborah Hellman, published in July 2025, and it's titled simply Algorithmic Fairness.
It's a fantastic source.
It really is. And our mission for you today is to provide like a shortcut to being deeply well-informed on this topic. We want to take you inside the mechanics of these systems to show you why making an algorithm quote-unquote fair isn't actually just a math problem. It's a massive, unresolved philosophical puzzle.
Yeah, but before we get into the weeds on that, I do think it's vital to state something up front.
Oh, right. The
Yeah.
disclaimer.
Yes. Our source material tackles some very real-world examples involving, race, sex, and the criminal justice system, and it draws on perspectives from all across the political spectrum.
Which is heavy stuff.
It is. Because of that, we need to be very clear to you, the listener. We are not taking any political sides today. Our goal is just to impartially report the philosophical frameworks and the statistical concepts contained in these sources.
Right.
We basically want to give you the tools to understand the architecture of this debate, rather than, telling you what to think about it.
Okay, let's unpack this. Because the whole field of algorithmic fairness, it practically exploded into the mainstream back in 2016. And it was all thanks to this piece of software called Compass.
Yeah, the compass controversy really is like ground zero for this entire area of study.
Right. So Compass is an algorithmic tool used by various states and localities in the U.S. to predict recidivism.
Which basically means the likelihood that someone who's arrested will go on to commit another crime.
Right. And judges and officials use these risk scores to help make decisions about things like bail and parole. And I think it's important to note right away that the Compass algorithm does not ask for a person's race.
Right. It doesn't.
It bases its predictions on a long questionnaire about, criminal history, associates, lifestyle, things like that. But then in 2016, the investigative journalism group ProPublica published this massive bombshell report.
They did, and they claimed the algorithm was biased against Black defendants.
Yeah, and the creators of Compass pushed back hard. They were like, look at the math, it is completely fair. So, I mean, how could both sides be looking at the exact same numbers and walking away with two totally different definitions of fairness?
Well, they essentially collided over the concept of comparative fairness.
Okay, what's that?
It's the fundamental idea that fairness means treating like cases alike. But the problem is they were measuring what alike means using two mathematically incompatible frameworks.
Meaning they were just grading the test differently.
Exactly. So the creators of Compass relied on a metric called predictive parity, which means the algorithm's output score has to mean the exact same thing for everyone.
Okay, give me an example of that.
So if the algorithm gives a Black defendant and a white defendant the exact same high-risk score of, say, an 8,
Okay.
the actual statistical likelihood of them reoffending in the real world is the exact same. An 8 means an 8, completely regardless of race.
Which, I mean, that sounds completely fair on the surface, right?
Yeah.
If the score correlates to the exact same real-world risk for everyone, That feels like the very definition of objectivity.
It does, but ProPublica was focusing on a totally different angle. They were looking at the errors the machine was making rather than its successes.
Oh,
They focus on a metric called equalized odds. Specifically, they were looking at the false positive rate.
meaning the people the machine got wrong.
Right. ProPublica isolated the defendants who did not go on to reoffend, the people who ultimately just stayed out of trouble. And when they looked at that specific group, the black defendants were almost twice as likely to have been incorrectly labeled as high risk compared to the white defendants who also stayed out of trouble.
Wait, let me make sure I'm following this. So if you are a black defendant who isn't going to reoffend, the machine is hitting you with a false positive much more often than a white defendant in the exact same situation.
Correct.
So wouldn't the obvious solution for the engineers just be to, I don't know, tweak the algorithm? Like you just tell the machine, hey, fix the false positives, but keep the predictive parity.
Well, what's fascinating here is that we mathematically cannot do that.
Wait, really? We can't?
No. Shortly after that ProPublica article came out, computer scientists actually proved what is now called the Kleinberg-Shidachova impossibility theorem.
That is a mouthful.
It is. But it's essentially a mathematical proof showing that unless the base rates of the two groups are absolutely identical, an algorithm literally cannot satisfy both of those fairness metrics at the same time.
Okay, I think we need to define that. What exactly is a base rate in this context?
A base rate is simply the underlying statistical likelihood of something happening in a specific group as a whole. So in this historical data, the overall rearrest rate, the base rate, was just higher for black defendants than for white defendants.
Okay.
And when those underlying averages are different, the math just locks up. Any algorithm that achieves predictive parity will automatically, mathematically, produce unequal false positive rates.
That feels incredibly counterintuitive. It's like trying to balance the passing rates of two different driving schools, but say one school only tests its drivers in a quiet, empty suburb,
Right.
and the other school only tests its drivers in, like, downtown Manhattan rush hour traffic. The base rate of difficulty is completely different.
Yes, perfect analogy.
So no matter how perfectly fair and objective the driving examiner is on an individual level, the overall fail rates can never naturally equal out. You either have to lower the standards for the city drivers or just accept that more city drivers will fail. You basically have to choose your metric.
That analogy captures the mechanical reality perfectly. The math literally forces us to choose. And this is the exact question philosophers are wrestling with right now. How do we choose which metric actually matters more?
Right.
And to answer it, scholars suggest we have to look entirely outside the algorithm itself and evaluate the real-world consequences. A scholar named Sandra G. Mason points out something really insightful here.
What does she say?
She says, imagine if the COMPAS algorithm wasn't being used to decide who stays in jail. Imagine if it was instead being used to decide who gets beneficial services.
Like what? Like job training?
Yeah, job training, housing assistance, free counseling, that sort of thing.
Oh, wow. Okay, so if the algorithm was handing out free counseling and it had a higher false positive rate for a disadvantaged group, meaning more people in that group were mistakenly flagged as high risk and therefore received the free services, nobody would view that as morally unfair.
Exactly.
In fact, society might actually view it as a net positive.
Right. The underlying math is exactly the same. The statistical error rate is exactly the same. But the moral judgment changed completely, just because the consequence shifted from prison time to beneficial services.
That is a massive perspective shift. It basically proves you can't just look at the code. You have to look at the human context the code is operating within.
Absolutely.
But, that entire debate is still focused on comparing groups, right? Black defendants versus white defendants. What if an algorithm is, like, highly accurate across all groups overall, but it just completely messes up for you as an individual?
Ah, yes. This brings us to what scholars call non-comparative fairness.
Okay.
It shifts the focus from how you are treated compared to someone else to whether you are being treated arbitrarily.
Yeah, and the Stanford entry uses a fantastic hypothetical for this. Let's look at the Jamila problem.
I love this example.
It's so good. So imagine a bank uses a sophisticated AI to approve mortgages. And the AI is incredibly accurate generally, but just by pure random chance, the historical data it was trained on happened to include a cluster of people named Jamila who defaulted on their loans.
Right, just a fluke.
Yeah, totally arbitrary. There's no racial or socioeconomic reason behind it in the model. It's literally just a weird statistical anomaly in the spreadsheet.
Right.
But the AI's pattern recognition engine learns, oh, people named Jamila are a bad financial risk.
Right.
Now, A new Jamila walks into the bank. She has great credit, a steady job. She applies for a loan, and the AI denies her instantly just because of her name.
Yeah, and if you are Jamila, you rightly feel you have been treated horribly unfairly. You're being judged on a completely arbitrary factor.
Definitely.
But philosophers Kathleen Creel and Deborah Hellman argue that arbitrariness alone isn't necessarily a full-blown moral crisis.
Wait, really? It feels like a crisis if you're Jamila.
Well, sure, a single weird computer glitch at one specific local bank denying you a loan is frustrating. But you can just go to a different bank down the street. It crosses a threshold into profound unfairness when it leads to what they call systemic exclusion.
Oh, I see. Because if every single bank in the country buys that exact same algorithm, Jamila can never buy a house.
Exactly.
She is permanently locked out of the entire housing economy because of a math quirk.
Yes. And this idea of systemic representational harm, it's not just theoretical. Consider how search engines operate.
Okay.
Scholar Sophia Noble famously documented how searching for the phrase "black girls" disproportionately returned pornography compared to other searches.
Oh, wow.
Yeah. And LaTanya Sweeney found that searching for black-sounding first names was significantly more likely to return ads for arrest record background checks.
That's awful.
It is. And the engines weren't programmed with malicious intent, right?
Yeah.
They optimized based on human click-through rates. They crowdsourced our societal biases and served them back to us as definitive search results.
Wow. But here's where it gets really interesting, though. Because sometimes the algorithm isn't relying on a stereotype, and it isn't experiencing a random glitch either. Sometimes it's just doing exactly what we built it to do.
Yeah.
Optimize for economics.
Yes, the market effects.
Right. So the entry mentions this study by Lambrecht and Tucker about an online ad campaign for careers in STEM, science, technology, engineering, and math. And the ad was explicitly designed to be gender neutral to encourage more women to apply.
Right.
But the algorithm ended up showing the ad predominantly to men. And the mechanism behind this is just fascinating. Women, statistically, control more consumer spending. Therefore, women are a more highly coveted demographic for retail advertisers.
Which drives up the cost.
Exactly. It drives up the cost of buying ad space in front of women's eyeballs. So the algorithm is given a simple instruction. Get the most clicks for the lowest possible price.
Yeah, and it simply followed the economics of the digital ad auction.
Right. It bypassed women not out of misogyny, but because men were literally cheaper to advertise to.
Exactly. These are known as market effects.
But let me push back on this for a second. If the algorithm is strictly responding to market forces like just bidding on cheaper ad space in real time, is it actually the algorithm that's unfair, or is it just capitalism optimizing itself?
That's a great question.
Like, imagine you order a package, and the delivery driver's GPS calculates the absolute fastest, most fuel-efficient route across the city. But that route happens to completely bypass a specific low-income neighborhood. The driver isn't prejudiced against that neighborhood. They're just being efficient. Can we realistically call the GPS unfair for doing the math correctly?
That is the core tension of non-comparative fairness. Legal scholar Pauline Kim argues that, yes, we can and should call it unfair in certain contexts.
Really? Even if it's just efficiency?
Yeah, because she argues the law needs to address disparities in access to valuable opportunities, regardless of the algorithm's intent. If the result of that pure economic efficiency is that a protected group loses access to high-paying STEM careers, the efficiency itself becomes a vehicle for inequality.
Okay, I see that.
But it requires a delicate balance. As legal theorist Frederick Schauer points out, sometimes fairness requires treating people as highly specific individuals, but other times fairness actually requires us to completely ignore individual differences.
Like airport security.
Precisely. We make everyone walk through the exact same metal detector, take off their shoes, empty their pockets. We know objectively that not every single passenger poses the exact same level of risk.
Right.
Definitely not. But treating everyone identically, ignoring their individual profiles entirely, is the very thing that makes the security process feel legitimate and fair to the public.
We have been talking about these algorithms as if they are making independent judgments based on pure logic. But algorithms are really just mirrors, aren't they? They can only reflect the data we feed them.
Garbage in, garbage out.
Exactly. Which brings us to the data itself and what the source calls the flawed data dilemma. If our historical data is flawed, the algorithms are just going to inherit those flaws. And the source breaks this down into measurement error and fair representation.
Yeah, so measurement error is a pervasive issue because we often cannot directly measure the concept we actually care about. We have to measure a proxy instead.
Give me an example.
Well, law schools want to admit students who have great legal reasoning ability, but you can't, like, put a scientific instrument into someone's brain and quantify that ability. So institutions use the LSAT score as a measurable proxy for legal reasoning.
But there is always a gap between the proxy and the real thing, and that gap is measurement error.
Exactly.
And Sandra Mason takes this concept and applies it back to the criminal justice algorithms we discussed earlier. She calls it bias in, bias out. When an algorithm tries to predict who will commit a crime, it can't actually measure crime because a vast amount of crime goes completely undetected by authorities.
Right. So what concrete data do we feed the algorithm? Arrest records.
And arrest records are not a pure measure of crime. They are a measure of policing practices.
This is such a crucial point.
Yeah. If a specific neighborhood is heavily patrolled by police, perhaps due to historical profiling, more people there will be arrested for minor infractions compared to a neighborhood where police rarely patrol, even if the exact same amount of crime is happening in both places.
Yes. And then the algorithm ingests those arrest records and learns that the heavily policed neighborhood is inherently more dangerous, which then mathematically justifies sending even more police to that neighborhood.
It creates a self-fulfilling loop coded straight into the machine.
It does.
The other major data flaw the source highlights is representation. There was a landmark study by Joy Buolamwini and Timid Gebru. They looked at commercial facial recognition software, and they found the tools were highly accurate for light-skinned men, but failed miserably when trying to identify dark-skinned women.
Right. And the primary reason was that the training data was overwhelmingly male and white.
But the mechanics of how the AI failed are critical here, too, because it wasn't just a lack of diverse photos. The researchers found that the data relied heavily on photos of celebrities.
Yeah, which skews things weirdly.
Totally. Neural networks learn by extracting features. They look for pixel contrasts, edges, color gradients. And in celebrity databases, female celebrities tend to wear significant amounts of makeup compared to male celebrities.
Sure.
So the AI's feature extraction engine essentially learned a false mathematical rule. Heavy makeup equals female.
Right.
When it encountered a non-celebrity woman not wearing makeup, or a woman with darker skin where the contrast features were completely different than its limited training set, the engine simply could not process the image.
It just broke down.
Yeah. But wait, let me make sure I'm wrapping my head around this. If the facial recognition failed, simply because of a makeup anomaly in a database of celebrities, doesn't that make it just a stupid coding error rather than a deep moral injustice?
How do you mean?
Like, take my robot vacuum at home. It always gets stuck on the black rug in my living room because its infrared sensors think the dark color is a cliff, and it just shuts down to avoid falling. It's an annoying glitch, but the vacuum isn't being discriminatory.
Ah, right, yeah. But if we connect this to the bigger picture, we really have to distinguish between an epistemic error, a mistake in knowledge or perception, like your vacuum, and a moral unfairness.
Okay, what's the difference?
Scholars argue that an error crosses the line into moral unfairness when it reinforces societal injustice. Your vacuum glitch doesn't harm an already marginalized group, but when a facial recognition system fails dark-skinned women, and that exact system is being used for, employment screening, building security, or law enforcement suspect identification.
Oh, I see. Then the burden of that glitch falls entirely on a group that already faces systemic hurdles. It's less about the glitch itself and more about who absorbs the damage.
Exactly. It ceases to be a harmless technical failure and becomes a mechanism that mirrors and amplifies existing societal neglect.
Wow.
Which really brings us to what might be the most difficult part of this entire philosophical puzzle.
What's that?
What happens when the algorithm is flawless, the training data is perfectly accurate and perfectly representative, and it still discriminates?
Wait, if the data is 100% accurate, how can it still be discriminatory? That feels like a contradiction.
Because the algorithm is making perfectly accurate calculations based on an unjust world.
Oh.
Yeah. Deborah Hellman refers to this as compounding injustice, and Benjamin Idelson calls it patterned inequality. If historical injustices like redlining, segregation, or discriminatory hiring mean that, on average, Black applicants have less generational wealth today than white applicants, a perfectly accurate, totally race-blind algorithm will still deny them loans at higher rates.
Because the data reflects the history.
Exactly. It is accurately reading the financial data, but in doing so, it is actively perpetuating the injustice of the past.
So the standard response is to tell the algorithm, hey, you are legally forbidden from looking at race or sex. You just remove those columns from the spreadsheet entirely.
You'd think so. But machine learning models don't work like traditional spreadsheets. If you blind the algorithm to race or sex, its optimization engine will simply hunt for workarounds to achieve its predictive goals. This is called the proxy problem.
Ah,
The classic example is ZIP codes. Because of historical housing segregation in the US, where you live is highly correlated with your race. If an algorithm uses your ZIP code to predict loan repayment, it is effectively using your race, even if the word race never actually appears in the code.
and the source material details this incredible example about sex discrimination to illustrate how relentless these engines are.
Oh, the hiring one?
Yes, an algorithm was tasked with finding good software engineers. So it scanned the resumes of past successful and unsuccessful hires at a specific tech company. And it figured out that people who graduated from specific women's colleges, like Smith or Wellesley, didn't stay at this company very long in the past.
Right.
It didn't know why. I mean, perhaps the company had a hostile work environment for women, but the algorithm only sees mathematical correlations. So it assigned a negative weight to the words women's college and started systematically downgrading any resume that included them.
It's wild.
It wasn't explicitly looking for the word female, but it found a proxy.
Which leaves legal scholars with a massive headache. Like, how do we define what counts as a forbidden proxy? Is it any statistical overlap at all, or does it require negative intent?
Right.
The U.S. Supreme Court actually looked at the foundation of this in a famous case called Feeney. It involved a hiring preference for military veterans in civil service jobs.
Right.
At the time, almost all veterans were men, so the preference massively disadvantaged women. But the court ruled it was not a proxy for sex discrimination because the legislature's intent wasn't to harm women, it was simply to reward veterans.
So what does this all mean for our AI? Let's go back to the ZIP code example.
Yeah.
I get why we would want to ban the AI from using ZIP codes because they act as a proxy for race. But ZIP codes also correlate with median income, local property values, school quality, all things a bank legitimately cares about when assessing financial risk.
Yeah.
If I ban the algorithm from using ZIP codes entirely, haven't I just blinded the machine to perfectly valid financial data?
You have put your finger on the absolute hardest part of the proxy debate. Scholars Anya Prince and Daniel Schwartz argue for what they call the information value approach.
What's that?
They say a proxy should only be banned if it predicts the outcome only because it correlates with a protected trait. So in the women's college example, the college name only predicts poor performance because it correlates with being a woman in a hostile environment. Banning that proxy makes complete sense.
But the ZIP code predicts loan repayment for a dozen financial reasons, not just because of its correlation with race.
Exactly. But Hellman, the author of our source, argues for a broader explanatory account. She says a proxy is problematic if it picks out people specifically because of prior injustice like housing segregation.
That makes up with two.
And philosopher Shannon Valor has a brilliant concept that ties this all together. She calls AI the AI mirror. These algorithms aren't alien intelligences. They are just showing us society's own reflection. When a seemingly neutral data point like a ZIP code causes massive racial disparities in a computer model, the AI is forcing us to confront how deeply past injustices are woven into the very fabric of our everyday data.
Wow. So the AI isn't the problem. It's the messenger showing us the problem we haven't fixed yet.
Exactly.
Well, we have covered incredible ground today. We started with the mathematics, proving you literally cannot have perfect fairness if groups start from different baselines, the Compass impossibility theorem. We looked at Jamila getting arbitrarily locked out of the system. We saw how biased data, like makeup on celebrities, breaks facial recognition. And finally, we explored how machine learning models hunt for proxies, acting as an AI mirror that replicates past injustices through seemingly neutral data points.
Understanding these frameworks completely changes how you view the infrastructure of the modern world.
To you, listening right now. The next time you apply for a credit card, or see a strangely specific job ad, or read a headline about a new AI breakthrough, you now know that this machine is swimming in deep philosophical waters. It's not just math, it is morality translated into code.
Absolutely. And I want to leave you with one final provocative thought built on this research. Scholars often refer to the double standard of inscrutability.
What's that?
Well, when a machine denies us a loan or a job, we demand explainable AI. We demand a perfect, logical, mathematical breakdown of exactly why it made that choice. But the human mind is the ultimate black box. A human loan officer might deny you because they subconsciously disliked your shirt or they were tired, and they will never be able to give you a mathematical explanation for their bias. We must ask ourselves, are we demanding a level of perfect fairness and transparency from our machines that human beings have never been able to achieve themselves?
That is a question that is going to stick with me. So, the next time you are standing in that kitchen holding the knife, staring down at that chocolate cake, and the kids are arguing about birthdays and skip lunches, well, just remember, even the supercomputers haven't figured out how to cut it perfectly either. Thank you so much for joining us on this deep dive. Keep questioning the algorithms around you.